Hi everyone and welcome back to the first lesson of the course. Today we are going to learn the last basic features we should know, linear and circular pattern, fillet and chamfer, shell, mirror and rib. In the next lesson we'll apply everything by creating mechanical components using all the features we've seen. So let's start with linear and circular pattern features. They work similarly to the sketch pattern commands, but instead of repeating 2D sketch elements, they allow us to pattern 3D solid features or bodies. To understand how they work, we'll create a gear where the pattern will be used to replicate the tooth. We start by creating the base cylinder. We select the top plane as the sketch plane and we draw two concentric circles. Now we dimension it, the other with 38 millimeters and the inner one 12 millimeters. Now we have to extrude it by 10 millimeters and our body, our cylindrical body is created. Now we have to create the tooth. We start a new sketch on the top face of the body. We draw a vertical center line from the origin and two vertical lines with the starting point coincident with the external circumference. Now we have to add the constraint to the lines and for this reason we select the two lines and we make them equal. The second constraint that we have to apply is the symmetric constraint, and now we have to create a circle with diameter 44. And we trim the unnecessary part of the two lines. We have to define also the distance of the line from the center line. This has to be 2 millimeters, and the sketch is fully defined, but we have to close it, otherwise the extrusion command doesn't work. To do it, we introduce convert entities. This command allows to convert the selected edges into identical entities by projecting them in in the sketch plane. So we can select the external diameter of the cylinder and convert it in our sketch plane. Now we with the trim entities we remove the arc outside the lines, these two lines, and leaving a closed tooth profile. We extrude the profile and we can do the extrusion by with blind command and 10 millimeters length, or also with up to surface and select this phase of the cylinder. Now the first tooth is created, and we can pattern it. So we click in circular pattern, and we define the parameters of the feature. For direction 1, we can select any of the circular edge, it doesn't matter which, we select this one. With the distance spacing, we can set the angle of distance between the teeth, but in this case we check on equal spacing. And with the two boxes, these two boxes, we can decide the angle of the pattern and the number of instances. In this case we set 20 instances. With direction 2 we can define another pattern with different parameters, but the direction remain the same of the direction 1. In features and phases, we select the feature or the phases to pattern, and we select this, and we open the design tree, and we select boss extruded too. If needed, we can use bodies to pattern if the feature didn't merge with the base cylinder. Reference geometry is not used because we provide with the direction in the first box, and we don't need any other reference. Clicking the pink dots appeared in the graphic areas. And clicking on OK generate the gear. Now let's do a quick example to explain linear pattern. We start creating a rectangle and then extrude it. So we use top plane, we draw our rectangle and extrude it with line condition. It's not important the length. Now on one phase we do the rectangle, we do another sketch. We select this one and we draw a circle in this angle. We don't dimension it to go faster. Then we extrude it 5 millimeters and open the linear pattern. Now we select as direction one side of the body. We can also select two different direction with direction 2 to create two different patterns. So we select in direction 1 one side of the body, and in direction 2 the adjacent body, the adjacent side. With the arrow we switch the direction, and we set the number of instances, and also the spacing between the different instances. We can increase the number of instances, and the rest of the options are the same of the circular pattern. We also have feature scope to select the bodies that we want to involve in the pattern. With full preview, we see if the pattern is correctly designed. We click on OK, and we have our pattern. Next, let's introduce Fillet and Chamfer, two essential tools for modifying edges. Start with Fillet. In the command manager we have fillet type, but the most common option is the first one, the constant size fillet. In attempts to fillet, we select edges or faces in the graphics area. When selecting an edge, a quick selection bar appears to help to choose all tangent edges. And in fillet parameters, we set the radius, and the profile of the fillet between circular, conic, or curved or continuous. We have to set a radius not too big, otherwise will appears an error. So we create our fillet. We can also select multiple edges at one, and the chamfer command has three main types. Angle distance, we can set the angle and the horizontal distance. Distance to set horizontal and vertical distances. And the third vertex is used to chamfer vertex. As with fillet, we can select an edge to chamfer and use the quick selection toolbar for multiple edges. With the first type, we have to choose to set the chamfer. And the angle of the chamfer. Another important feature is mirror. It works similarly to the sketch mirror command, but instead of reflecting to the sketch, it allows us to mirror features and bodies. Let's look at how this command works by creating a semi-cylinder, then using the mirror command to complete the second half. For begin, open the sketch in the top plane. We draw a vertical line, and then use the 3-point arcs to draw a semicircle from the end of this vertical line. We define the radius, and then another vertical line from this point to close the other point. To draw the inner profile, we select offset entities, we uncheck select chain, and we set these parameters like 2 millimeters. That will be the thickness of the cylinder. Now we select the arc, we click on OK, and we trim the unnecessary part like this and this edge and these two edges. Now we have to apply the constraints, so we select these 2 points of the line and the center of the arc and make vertical. We have to define also the radius of the arc. We set 30 millimeters, no, 50 millimeters, and this line, this length of the line is driven by the offset between the two arcs. So at this point we can open the extruded boss base command and extrude the profile like 55 millimeter. We obtain our semi-cylinder. Now we select mirror, and for mirror face we select the cylinder section, this face, and the features is already selected in features to mirror. We can click OK. Appears an error. If the feature hasn't merged with an existing body, we have to delete this one, and in bodies to mirror select the semi-cylinder, and OK, our cylinder will be created. Obviously there's faster methods to create this cylinder, but we needed a simple geometry to see how the mirror commands work. The next command is shell. This command allows us to hollow out a solid body by removing selected faces and leaving thin walls. And it works with any solid geometries for which a constant thickness can be defined. To use shell, click on shell command, and in parameters we have to set the thickness of our body. We put 2, and then we have to select in this box one or more faces to remove them. we select this one. This faces selected will be open in the final all-load body. So we click OK. And OK. See, our body will be created, and this body becomes a team world component. The last feature we'll cover is the rip command. This tool allows us to add team world supports to a solid body by adding material along one or more sketch contours. Ribs are typically used to increase the strength of a part, especially in areas that are structurally weaker. To create the rib, we need an L-shaped body. We start a sketch in the top plane, and we draw two rectangles side by side, and then with trim entities we removed the line between them. So we have a L-shaped close profile. We can extrude it. Okay. Now we have to draw another sketch, and the plane will be at the 8 where we want to place the rib. In this case, if we want to make the rib in the center, we have to create a plane. So we select this and flip the offset, put set 55 millimeters, so 27 millimeters. Now we can create the rib in the middle of the body. We select sketch a single line in this plane, and we dimension it. We dimension the angle relative to the horizontal line, 45 degrees, and fundamental thing is that the line must be intersect the solid body, otherwise the command will not work. Now we can also define the distance between these 2 points. Now we select ripped, activate the ripped command, and in the options we can set the direction and the thickness of the rib. If the preview arrow, like in this case in the graphic area, points in the wrong direction, we can flip checking this flip material side to place the rib inside the body. We can decide the direction of the thickness. We set by the mid plane, and also its length. In selected body we make sure to select the L sheet body. And click on OK. Now the rib is created. We can also create more ribs at one time. Just create multiple sketch in different plane and then select all in the selected contours box. These are the key features you need to know for now. In the next lesson we'll model a pressure vessel to see how we can create a complete object using these features. If you found this video helpful, please subscribe and like the video to support the channel. For any questions or doubt, leave a comment below.